Thanks a lot for the introduction. Shall I go? All is fine?
Yes, fine. Thank you very much.
Thank you, and thanks a lot for having me here this morning. Very happy to present to you my executive work, which is basically revolving around the question of how to understand better debates related to societal issues online by the help of structuring knowledge in the form of knowledge graphs and all kinds of tools and applications that we can construct by the help of knowledge graphs built on top of this kind of data. So since we're talking about societal debates on the web, maybe let's first have a look a little bit on the web. So as we all know, historically, the web has been conceived as a web of documents where, thanks to basically keyword-based search, we can find or access rich sets of resources like documents, images, videos, and whatnot. For example, if you type Brexit, you would most likely find a lot of documents and resources related to this particular historical event. However, we are currently, for a couple of years now, in the paradigm or in the movement towards a novel paradigm of web where we have this kind of wish to transform the web to a kind of a big database where we can more easily access in a structured manner information. And this is where knowledge graphs, in part, play a very important role. And so, since I don't assume much knowledge about what knowledge graphs are, and if this is the case, I excuse myself, but I will just introduce very briefly what we mean by knowledge graphs. So these can be seen as an abstraction of way of organizing the knowledge that we have about this particular topic or particular field, and specifically doing this over the web. So the building components of a knowledge graph are entities and relations between these entities. So what are the entities? This can be pretty much anything that you can think of, like starting from individuals, pieces of art, cities, monuments, and whatnot, or even more abstract concepts. And relations are more or less arbitrary links between these entities. And what's interesting is that we can also have different levels of semantics in expressing this knowledge. So we can have entities, but also some specific kinds of entities which are more like classes or concepts, meaning in the sense that a particular individual can be defined as a type of a specific class, which is a type person, for example, right? And adding those kind of triples, like two entities related by a link together, helps us build a richer network of information, which appears to be very useful nowadays to integrate information which is extracted from different data sources on the web or elsewhere, for example, in specific scientific projects or industrial projects. What is interesting is that the relations between these entities and specifically the, so to say, the ontological layer that I just mentioned, helps to build a very high level semantical representation of knowledge. So in most of the cases, these are humans who are actually doing this job most of the time. So if we talk about highly curated knowledge of very good quality, which contains high-level semantics, and for that reason, it also can be used, although it's like more part of the symbolic branch of artificial intelligence, but it can be combined with machine learning. This is things that we are doing currently. In order to enhance or incorporate more knowledge into, for example, language models or machine learning models who do not have this knowledge explicitly. Okay, so knowledge graphs, this is a term that will come around very often over this talk. In particular, to come back to our story, so the web of documents that we were trying to move to another level where we could also include this kind of structured and explicit knowledge. This is where knowledge graphs play an important role. So in big part, thanks to knowledge graphs nowadays, we can, for example, obtain specific answers to specific questions. For example, when was Brexit referendum? We will get a precise date of this event instead of getting resources where we have to look up this information ourselves. So we see that there is kind of a paradigm shift taking place from keywords-based search towards more entity-centric search. right? And so we have seen a growing effort in different communities to build and make available publicly knowledge graphs and structured data on the web. And some of the success stories that we know about that are, for example, the Linked Open Data project, the Google Knowledge Graph, of course, and initiatives such as schema.org. And of course, all of that has been recently coined by the acronym FAIR, meaning findable, accessible, interoperable, and reusable data, basically describing the protocol of building and publishing structured knowledge on the web in a accessible and reusable manner. So that's all very nice, but is everything on the web a fact? And of course, we all have seen recently and in the past years that this is not the case. And especially when we talk about topics which are of certain controversy, we have seen that many things that appear on the web, information that appears on the web, is not specifically a fact, in particular not a fact that we can store in a knowledge graph. And this is where we have this proposal, so to speak, of adding an additional layer to the web, where in addition to the documents and facts that we can access nowadays, we could also model online discourse data, model represent and access model online discourse data, in particular claims. For example, if you would like to see or learn what pro-Brexit claims of right-wing politicians have been made recently, for example, currently we cannot really access this in a structured manner like we could do this for the date of the Brexit referendum. Okay, so the problem here is that, yes, there is an abundance of discourse data, for example, claims, viewpoints, opinions on various controversial topics, as well as their context and so on. However, knowledge graphs of today are focused on facts, and this kind of data, in particular claims, are more complex and not exactly facts, as we will also see in the following slides. So there is a need of shared understanding and shared structured knowledge about online discourse, and this is what we identified as a gap currently. Of course, when we talk about online societal debates, the field on the topic of misinformation and disinformation kind of appears a prominent use case scenario, right? And we have seen that there is a growing amount of work on that, specifically in the AI field and also in intersection with other computational sciences, to understand and analyze the spread of falsehoods, the spread of biased discourse, propaganda, manipulation, and so on. So all these questions that you see here, for example, how to assess the veracity of a claim, basically doing fact-checking, right? How to understand what is the stance of a particular claim. Those approaches, computationally speaking, they need to build on specific labeled, annotated data, so ground truth data, with truth value labeled claims. So we need this kind of to access this kind of information in order to build systems like that. On the other hand, in very specific fields outside of the AI domain, where you've seen like social scientists, for example, journalists or fact checkers, they need to be able to access information. For example, looking into all false claims by Donald Trump that also mentioned the FBI, for example, something like this. Retrieval claims mentioning journalists and whatnot. So all of that is actually available on the web in one form or another. But if you want to obtain the responses to this information needs, you will need to actually manually, more or less, look up different sources like fact-checking portals, encyclopedia, knowledge bases, and whatnot. So what we identified here is the need to enable retrieval of claims-related information in a more centralized manner. And some such resources have already been developed over the last couple of years, but what we have identified is that they are mostly limited in size, they're mostly static, and all of them lack metadata and shared data model. So this is where we propose to build and build the claims knowledge graph, or ClaimsKG, which is a knowledge graph of fact-check claims, but also it is, of course, a data set which is openly available. It comes with a schema, so a specific data model which helps us represent this kind of information and knowledge, as well as a bunch of tools for its construction, so basically so that anyone who would like to rebuild something like this on their own, they could do it. and a set of applications, like mostly web applications, which are publicly available, which help us in a user-friendly way to access the information which is stored in the knowledge graph. And this is what I'm going to talk about in following minutes. So we talk about claims, but what is a claim? And my aim here is not to start a debate, but rather to insist on the fact to what extent it is a question. So there is little agreement on what a claim is across different disciplines. If you take and look at a dictionary, you find a definition which is not exactly the definition that, for example, fact checkers would use, and which would be different from the definition that the argument mining people, for example, would use to define a claim, which themselves don't exactly agree on what a claim is. And then if you go to the field of question answering, then again, you'll find yet a different way of formulating what a claim is, and so on, and so on, and so on. So we identified here the need for shared and centralized understanding of what a claim is, motivated by the fact that it appears that a claim is a complex notion. So its interpretation is not explicit, it's not immediate. It usually depends very strongly on specific context. For example, when and at what event, at what occasion this claim has been uttered, by whom, and so on. So there is a need for clear definitions and structured knowledge about a claim. So what we have proposed in a recent paper is a conceptual model to represent claims, which has these three very simple components. Where we find in the center what we call claim utterance, or basically the actual verbal expression of the linguistic expression of the claim. Then we have something that we call the context, which would help understand the proposition, meaning the actual meaning of the claim, what the claim is about. I will not go into much detail here, but the idea is that the proposition contains information which helps understand the meaning of the claims. So this is what we can disambiguate, for example, to utterances which may appear very similar in their linguistic expression. And the context is basically the component which helps produce this disambiguation. So this is where we find information related to those very simple questions like who, where, when, and why uttered a particular claim, a particular assertion. Right. So this here shows the conceptual model that we have built, or rather an instantiation of the conceptual model that I just presented. Without going into details, what I'd like to just focus on here is that what you see is that we have these three main blocks: in red, the proposition, sorry, in green, the proposition, in pink, the utterance, and in yellow, the context. And we have two different utterances, which, if you look them up, are shaped quite differently, linguistically speaking. Actually, they're shaped quite similarly, sorry, linguistically speaking. One would assume that they probably have to say the same thing. They have different contexts also. And by adding these different contexts, we understand that they both have the same proposition. So this is what the model helps us or allows us to represent, basically utterances that are different in their expression and may have different contexts, but do say the same thing. So in this talk, or in the remainder of this talk, when we talk about claims, we will be talking about statements that have been reviewed by fact-checking organizations. What we mean by that is, for example, just taking a recent claim from PolitiFact, which is an American fact-checking organization. This is how it looks like at their portals, at their websites. So you have the claim itself in inverted commas, like Chinese military convoy enters Ukraine from Russia. The journalists, fact-checkers have assessed this as being a false claim. And then you have a bunch of, for example, keywords that come with that. Also, if you look into the website, you'll see that there is a whole article which comes with this claim, where the journalists explain what is the pathway they have followed in order to arrive at their conclusion that the particular claim is false. And what we have done is basically, in the first place, adapt our claims model that I just presented for the purposes of specifically modeling fact-checked data, fact-checked claims. And I will very briefly present this model here. So without again going into each particular element of it, we have a couple of main building blocks. So we have used mainly the schema.org vocabulary, which is very convenient for modeling this kind of information. And what we can see here is that we have information about the fact-checking organization who has published this claim and who has reviewed it. Then we have information about the actual review. The actual claim is contained in the creative work class, where we find components such as the keywords associated to it, its actual verbal expression or linguistic expression, so the text of the claim, the date, so these are more like contextual elements, with some annotations, more like linguistic annotations. And then what we have in yellow here would be the ratings or the truth values that have been associated to the claim by the fact-checking organization. So what is important here is that this model basically allows us to represent this information and access this information. And the link here, which is important, is that a truth value associated to a claim is associated via a particular fact-checking organization, which means that there is no claim of universality of this truthfulness or untruthfulness. So how have we proceeded now? We have a model, we have identified our sources, which are the fact-checking websites. Currently, the ClaimsKG knowledge graph starts from taking information from the website that you see here. So I think there is like 10 or 12 of them or more. So they're in different languages, mostly related to politics, but still country-specific in the sense that the facts or claims that are verified in the UK are not the same as the claims verified in France or in the US and so on. What we have done afterwards is extracting from each of these sources the information that we need in order to instantiate our model. Basically, that is the text of the claim, its truth value, the text of the article, which we call the claim review, provided by the fact checkers. Any kinds of specific references that might come with, for example, references that helped us assess the veracity of this specific claim. As I mentioned, the entities which we can find there, and more contextual information like author, dates, and so on. As said, we focus on extracting and annotating specific entities from the text of the claim and from the text of the claim reviews, so that if we talk about Joe Biden, for example, at one particular claim, we know that this is the entity Joe Biden, not just a string of characters. And then we lift all this information towards our knowledge graph, which we publish publicly. Sorry. And on top of that, we built a bunch of applications which help us browse and understand all this stored information in a more easy and user-attractive way. And this is what I will be talking to you about now. So for some reason, this following slide doesn't want to show, but what we were supposed to see here were the statistics of ClaimsKG. So I will just give you the number. Currently, we have almost 60,000 claims stored with their metadata, which makes ClaimsKG the largest currently available resource of fact-check data. So going to the applications, what can we do on top of this knowledge graph? For the first place, what we'd like to provide to users with different backgrounds is a easy possibility of exploring our data. Exploring means retrieving claims from specific politicians or public figures, retrieving their truth values with relation to a particular time frame. For example, say I'm interested to the US elections, midterm elections this year, so I would choose a time frame which is around this specific event and retrieve and explore data from this specific time frame. We'd like to propose ways of accessing the claims references and the journalistic reviews understand their statistics, for example, different trends that we could discover. When was the peak of false claims, for example, last year, and on what topic? So these are things that we can actually extract from our data. Or trends like how have falsehoods about immigration been spreading over the last 7 years, for example. Again, allowing us to observe specific peaks of this particular topic over the years and related to specific events, for example. And of course, as I mentioned in the very beginning, as in main motivation of this work, we can extract label data out of our data set in order to train fact-checking tools, or apply this to any other downstream task that one could imagine related to fact-checking. So this is how our web explorer environment looks like. It provides the means of doing faceted research in the search engine, choosing specific keywords or named entities, truth values, time periods, sources, meaning basically what in which fact-checking portals we would like to tap in. And this is what allows us to obtain the results as a list of results, as you can see here on the right. We can explore those, but also we can export them in a structured manner, for example, as a CSV file or as a RDF, like knowledge graph, more structured data. We can also access various references, keywords, annotations related to each of these claims if we click on them. So I think now, currently, the application is down because we discovered a little problem just a couple of days ago, something a little bit funny, which for specific websites, for some reason, the claims were pointing out to something completely different and kinds of content that we do not want to show. So we put this down for a while until we understand what is happening, but it will be up and running soon again. Another tool that we developed is the statistical observatory, which as mentioned, helps us observe and study and understand various trends, for example, related to topics and how those topics evolve over the years with respect to specific political figures and falsehoods and propagation of false messages and so on. And finally, the third application that we have made available is what we call the Claim Linker, which is a web service, but also an API, which allows us to annotate on the fly random text with claims that have been fact-checked, mainly coming from the ClaimsKG knowledge graph. So this offers the kind of a semantic annotation of unstructured content, but in a novel way. So for those of you who are aware of the entity linking task, for example, this is a very similar issue. The entity linking task, what it aims to do is you take random text, you find an entity in there, for example, the president of France, and you're able to link this to a specific entity in a knowledge base, in a knowledge graph, which designates the president of France. Okay, so here the task is a little bit more complex in a certain way because we are annotating not specific single entities, but whole pieces of text which correspond to claims that we store in our knowledge bases. For example, what you see here is this kind of snippet where if you run our tool, we'll be able to identify that in there is a part of the text which corresponds to a claim that we actually already store in our database and link it to this database. So the problem is defined as follows. We have a knowledge graph of fact-check claims, like, for example, ClaimsKG. We take as an input a random piece of text, and as an output, we have a set of claim annotations, which have this form. So we have the text with it, the position where we identify our claim, and a ranked list of URIs of claims, and a score. Score meaning to what extent we are certain of the match between the text and our claim. So why this thing is actually useful? There are many reasons for that. So this is how the web environment looks like. So basically, you can insert a text here, and then you get a list of ordered results, ordered by the score of confidence to what extent actually there is a match between the text and the claims found in our database. So of course you can retrieve these different claims and annotate your text, but also you can access immediately to all metadata available in ClaimsKG like the author, the date of publication, the truth value, and all this data, that information that I already mentioned that we store in our knowledge graph. So again, why this is useful? Well, for a random user, it can be useful just to see whether, if you're in doubt in a specific affirmation, to check whether this has been already verified by any chance by a fact-checking organization, and if so, well, what is the truth value that they have assigned to this piece of information? For fact-checkers, this appears to be of particular usefulness. So journalists who actually do the job of fact-checking. Why? Because verifying the veracity of a claim is a very laborious task. It takes a lot of time, a lot of human energy. So by talking to different fact checkers, they have told us that actually they spend days sometimes trying to reach a specific scientist, for example, who has published a paper that has been debated in a tweet, and see, well, this is what they say about your paper discussing the vaccines. Is it what your results are really about? And he would be like, oh, this is partly true. This is not exactly what I published in my paper, and so on and so on. So you understand how time-consuming this task is. And so if a fact checker for some reason wants to verify a specific piece of information, it would be very useful for him or her to know if this has already been verified by some of his peers elsewhere, right? And for this kind of application, the claim linker tool can be of a specific usefulness. All right, so wrap up about ClaimsKG. As we can see, the idea here is to go towards more advanced and entity-centric research data related to claims and online discourse. So this can be done in a formal and structured way by using Sparkle queries. So Sparkle being the language to query structured data on the web, like knowledge graphs in the form of RDF. But also this can be done in a more user-friendly manner, as I just described here, our applications. So we are working in a close collaboration here with a computational social scientists in Germany. And so they have been so far one of our main users. And we have seen that these kind of resources appear to be very useful for specific use case studies in the social science research. For example, studies into agenda setting, into the evolution of political discourse about specific topics over the years, and so on. And of course, as already mentioned several times, these kind of resources come to support AI research by providing label training data. So what are the challenges now in front of us? Many of them, but I would like to talk about one of them in particular, which is the third one in this list. It appears, I think this is quite an important debate. So basically understanding what are the biases of this kind of data. So if you look into the papers who present automatic fact-checking approaches and methods nowadays, so many of them, if not most of them or all of them, rely on fact-checking data coming from those kind of resources that I just described in order to build their models and train their models. So the problem here, I think, is that those kind of web resources, like fact-checking portals, do contain inherently a lot of bias. And this is not to blame the organizations for that. I think they're doing a fair job in trying in the most neutral and objective way to provide and assess quality information. The question is that there is a bunch of, for example, editorial issues which come at the very beginning. What kind of information do you want to verify? So since we cannot check everything, there is a certain decision to be made. And already at this stage, we see that there's a significant bias come into the game. So, for example, you may systematically debunk assertions coming from extreme right politicians or right-wing politicians, and never do this for the left-wing politicians, for example. This would inherently introduce bias in the way that you present the data. But even if you look into the actual assessments of the claims, we have noticed that there is a particular bias coming from the fact of to what extent actually we look into the details of how the information is presented. So if you look into specific claims, it really suffices to remove one particular word, and then the whole meaning changes. And the question there is exactly to what extent this kind of specificity mismatch between the actual source and the published information is taken into consideration when the journalists actually issue their assessments. So there is plenty of limitation, and we're currently working on a study to really better understand and underline those biases which come with this kind of data, which again, as said, appears to be a very, very valuable source nowadays of training data for fact-checking, automatic fact-checking models and algorithms. Okay, so before I finish, I would just like very briefly to talk about a couple of other knowledge graphs related projects. So when Laurent contacted me, he said, would like to talk about knowledge graphs. So later on, we converge more to the idea of presenting a specific application, which is more in the field of online debates and fact-checking. But let me very briefly introduce to you a couple of other projects that I'm currently leading, related also to knowledge graphs and to a certain extent related to the topic that we just discussed. So in a very, very, very tight relation to what I just talked about, we are currently looking into this question of like, what is this information about? And we see that, well, there are two main aspects that define this information, and one of them is spreading falsehoods, and the other one is doing this intentionally with the intention to do harm. And most of the research currently goes into the first part, so understanding if something is true or false, just like what I presented so far. But little attention is paid to the second part, which is understanding what is the actual intention of claiming something. And while talking with a communication scientist or a social scientist, they will tell us, well, what communication is about is intent. It is not about what you're saying, it is about why you're saying it. And here is a very challenging question, right? So this is where we are currently in the process of building a project to try to answer, understand this question by bringing in a team of interdisciplinary researchers from linguistics to AI to social sciences to ethics and also law and whatnot, right? So these kind of questions, in my opinion, they cannot be tackled by AI experts alone. They cannot be tackled by social scientists alone either. So there is a real need of converging all these different fields together in order to provide meaningful answers and insights. So another project I'd like to briefly introduce is the AI for Sci project, which is currently running for 1 year now. So this is an INR funded project between Germany and France about understanding science in online discourse. So again, quite related to the topic of societal debates, but with a specific focus on scientific discourse in the sense of analyzing, for example, on Twitter, messages which in one way or another relate to scientific findings. For example, if somebody says 29 people die in Norway after receiving a Pfizer jab, well, this may be true, but largely taken out of context. And this kind of information, like scientifically based information, is often used nowadays in order to instrumentalize deliberately, for example, discourse, to introduce bias for pursuing specific political or ideological goals. And this has been going on both sides of the political spectrum. So if you look at the US elections, for example, a couple of years ago, you had Trump, who was totally anti-science, and everything which is in one way or another supported by scientists was kind of anathema for him. And on the other hand, you had Joe Biden, who was like, science is our God, right? And it's like the absolute truth, which is inscribed in marble. And neither of this is the case, right? And what this project aims to show, also because what we see is that scientific support proportionally is growing on Twitter over the past years. So what we're trying to see is how can we bring in and surface the missing context of science-related claims published on the social networks. And this context can be seen as in two parts. For example, the media context, which is more like on what kind of social platform this has been published by who, what are the viewpoints associated to this claim, and so on. And on the other hand, you have the scientific context, where we have a link of the claim to the scientific source, if such exists, with all the metrics of scientific quality which come with that. And in this way, what we aim here is to trace, detect, interpret, and classify scientific claims basically from Twitter this is where we're looking into now, and link those claims to both their scientific sources and their social media sources. And I'll finish with 3 more examples of projects without going into details that are going on currently. So I'm also working in very different fields, for example, in the immunogenetics with people in Montpellier, on building knowledge graphs on proteins with various applications in medicine and pharmacy. Also, another project, AgroLD, deals with plant sciences, supported by 2 INR projects currently running. And in the recent past, I also was involved in building the DOREMUS knowledge graph, which is a graph of musical works coming from 3 big institutions, cultural institutions in France, like Radio France, la BNF, and la Philharmonie de Paris, which was supported by the INR DOREMUS project back in the time. And I will stop here. Thank you for your attention, and happy to take your questions.
Merci. So do we have questions in the room or online?
Thank you for your presentation. I think this job is of public interest for obvious reasons. Regarding the ClaimsKG, I have a question about the pace of update of the knowledge graph. For example, as you mentioned in the presentation, on social networks, false information spread somehow in an epidemic way. So if, for example, we want to automatically identify a claim on Twitter as a fake news, is ClaimsKG a reliable possibility, or is it not updated fast enough in order to answer this kind of question?
Very, very good question. Thank you. Thank you very much. So, as said, what we are storing in ClaimsKG are claims coming from fact-checking organizations. So there is a certain inertia there, meaning that from the time of the actual publication of a claim, for example, on Twitter, to the time when this claim will appear on the fact-checking organization's website, there will be a little gap, more or less little, because there is time needed for the journalists to do their job of actually evaluating and assessing the veracity. So what appears on Twitter today, at this instance, will not be in ClaimsKG because it will not be also on the fact-checking website. But to come to the beginning of your question, which, as far as understood, is more on the dynamics of the actual dynamics of updates of the knowledge graph. So even if today a new claim is added to, for example, PolitiFact, it will not be in our data immediately, right? So what we do regular updates every, say, 2-3 months, also to check if all our URLs are still functional, because at some point a specific fact-checking portal may decide for whatever reason to change their URL schema, or, for example, just to restructure their website, which would lead to us not retrieving any information anymore from them, right? So this is a lot of work actually to maintain this resource, and luckily, our colleagues from GESIS in Germany are taking care of this currently. So there is somebody actually doing these updates regularly. And the last update was done just a couple of weeks ago, where we came up with our current version of almost 60,000 claims available.
Okay, thank you.
Thanks a lot for the talk. Have you studied a bit how the context of a claim can change over time if, for example, the term is to lose, like the president of France? So the context could change over time. Have you studied that a bit?
Mm-hmm. Yeah, that's a very good question. So many things to say here. First of all, what is stored in ClaimsKG is a specific piece of information, so a claim, coming with its context, which is relevant to the time of publication of this information. So meaning that if the claim talks about the president of France, we have also the date associated to the publication of this claim, right? So this is where knowledge graphs are actually very convenient, in the sense of they provide this kind of means of publishing facts which are not in the sense absolute truths. So a fact would come with a bunch of, or a claim in our case will come with a bunch of information which is related to this claim, which helps to situate it in a specific context. Your question is interesting in many aspects, specifically when we want to study how debates actually evolve over time on the web. And so, for example, more in relation to the AI for Sci project that I just mentioned, what we have noticed is, for example, discourse related to vaccines evolves a lot because the information that we had about vaccines has been changing and evolving very rapidly over the past years. And specific claims which were made in 2020 are no longer true in 2021, even though they have been supported by solid evidence. So what it means, solid evidence? Well, basically the evidence that we have at a particular time of the particular point in time, and this is something that can change. So the best we can do by providing those kind of resources is being very accurate in contextualizing each piece of information, and exactly this context is part of this context is the time of publication of this information, as well as its source, as well as the events that are related to that, and so on and so on. As mentioned also in the beginning of my talk, we cannot disambiguate claims. We cannot understand their meaning without this context, because of all the entities which are involved. There are some of them more or less complex, as you mentioned, some of them evolving over time, and so on. So this is the best that we can do about that when providing and publishing this kind of resources, is to make sure that the context, to the most of its complicity, not complicity, but completeness, sorry, is made available together with the publication of the claim. What use you can do out of that afterwards? Well, many different applications, as I said, exactly thanks to those kind of resources, we could in principle study those kind of trends. For example, how a specific context around a specific claim evolves over time. So this is something that could be formulated as a downstream task based on this kind of resources.
Thank you.
Karim.
Thank you so much for your talk. It was very interesting. I am Justin. I don't know anything about knowledge graphs, but I found it really interesting. I have a question. So it's a bit in two parts. So the first part is we talked about science and evidence. So maybe some scientific claims, they have different levels of evidence. So is it possible with this knowledge graph maybe to build something like an evidence score, which could evolve with time, or something like this? And a related question is, so for example, maybe you have a claim, and then you have a claim which is a contradiction to a claim that was made in the past. Is it possible, because I know like knowledge is not necessarily at the same level as logic, but is it possible to find this kind of contradictions? And for example, someone says this vaccine is safe, and another update says this vaccine is not safe, and both are fact-checked and both are true. I mean, with the evidence that we had at the time are true, as far as we know. I mean, the evidence pointing in this direction. Can you find like the sort of detect this kind of contradiction and put this in with the context and the evidence? How to explain?
Mm-hmm. Yeah, great. Very good questions also. So regarding the first question, claim and evidence, right? So specifically when you talk about science-related discourse, this is something that we're actually currently investigating. What we have seen so far, based on a preliminary analysis of the data that we have collected. So just opening a parenthesis, in the framework of this project, we have developed a model which is able to classify scientific discourse. So basically meaning, if you take a tweet, our model can predict whether it's related to science or not. So what does it mean exactly? I will not go into detail, but this is a real question as well. So what it means that something is science related or not. So we have defined a specific protocol with very clear definitions about that. So given that we have this classifier, we're able now, for example, taking data from ClaimsKG to extract only claims which are related to science. And your question here is like, this pair of claim and evidence is very important, and specifically when you have science-related communication. And what we have seen so far is that mostly fact-checkers, what they tend to do when they assess science-related evidence is to oversimplify the information. So basically meaning that there is a discrepancy or mismatch of the level of specificity of the information which is presented. So if you, for example, a study goes like, based on 200 samples, we have found that the vaccine in France is not efficient for people under 25. I'm just totally making it up, okay? What the fact checkers may take out of there is the vaccine is not efficient for people over, under 25. Well, a bunch of contextual elements are missing in the information which is presented by the fact checkers. And this is something which is going on quite frequently. So for that reason, exactly what we are trying to do now is to enrich our knowledge graph with, specifically in relation to science-related discourse, with explicit links from claims to evidences. And when I say evidences, is meaning that a specific claim can have multiple evidences, which can be also structured in a certain sense. Some of them being more higher level, and some of them being more detailed. The more we go into the detail, more we find actually the quality of the support or the debunk of a particular claim. In order to be able from there to go towards automizing this process, we first need to have this annotated data. And this is something that we're currently doing, basically building this corpus of claims and evidence for scientific discourse. I think I will have more elements to answer to you once we have this corpus and once we have run several experiments on that. Regarding the second question, so I think this is something which is quite in the field of the argumentation mining domain, which has been growing quite fast in over the past 5 or 10 years. So I haven't looked personally into that, but to me this is a question which is really one that the argumentation mining people are very much interested into. For example, in France we have Serena Villata, who is working on that for a couple of years now. She's quite an expert in the field. So I would rather not try to fabricate an answer here. But my intuition would be that with our data, what we can do is that if there is a kind of a mismatch or a discrepancy of the assessments of a particular claim across different fact-checking organizations, for example, this could be made explicit in our data. So what we have seen so far, just by trying to make very simple claim matches, is that the same claim evaluated by the same organization, actually we can find it sometimes, very rarely, but it can appear several times with different truth values. The reason being that, well, they have evaluated it once and it was true, a couple of months later it was no longer true for whatever reason. And the problem here is that you may consider this as a contradiction, but if you look at the time, the particular context of assessment, you understand that this is not really a contradiction, if this information is true.
Okay, thank you very much.
Some other questions?
Hi, thank you for the presentation. I think it's a very interesting use case of knowledge graphs. So you have this site that allows people to do queries themselves on the ClaimsKG from your kind of query builder, so that people don't have to be familiar with Sparkle. Have you looked into integrating like the systems that translate natural language into Sparkle queries or any kind of query? But I know.
Sorry?
I know, for example, Sparklist that was developed here at ERISA that aims to do exactly that, try to help people build a Sparkle query on knowledge graphs or from natural language?
Yeah, so we have not done that for the very simple reason that we are not actually for exploring our data. We are not dealing with a free text, right? So what you have are facets and specific categories of search. And what actually the linking that the system will do is link the text, for example, if you want to browse with respect to specific named entities, the system would match your text to a bunch of named entities that would be immediately proposed as options to the user. So if you start typing Donald, you will see scrolling down the menu choices like Donald Trump, Donald J. Jr., or whatnot, and you can choose what entity you're referring to. The same with keywords, time period, and so on. So basically, the Sparkle query is constructed based on these very fixed elements. So we're not dealing with natural language in its free form here, but that could be interesting to do if we were proposing a different way of accessing, like, for example, giving the opportunity to a user to just type in his or her query in a natural language manner, and then we transform it into Sparkle. But this is not what we have been doing in this application. In the claim linker tool that I presented, this is more or less what is happening. So we have free text that we can insert, but what the system is doing is again matching this text to the text of the claims that we have in our knowledge base. So there is no Sparkle querying going on behind the scenes.
Questions here again? So I have one question. So earlier you were talking about the fact that sometimes something that is known today turns out to be, which is true, for example, turns out to be false in the future. Okay, that's normal. That's just the way things may be. Do you document inside the knowledge graph the process used by the people to discover the truth, or elements that tells them it's a false or true answer? I'm not talking about explanation of AI, I'm just talking about how do you encode the information that people use to decide that this is true or this is false. This is also encoded inside the knowledge graph to remember the reasons that were used to find whether this or that fact is true or false.
No, we do not encode that explicitly in the graph. So, as mentioned, what we do is that we use the text coming from the journalistic article, which assesses the veracity of the claim, in order to extract different elements and entities out of this text. For example, all kinds of named entities we can find, but also external references. So the best way for a human to understand how the fact checker has proceeded to come up with his or her evaluation is to just actually click on the link, which brings us directly to the fact checking website and read through the article. Implicit knowledge about that is available in the graph, again in the form of contextual network. So at what point in time this has been verified by whom, at what point in time this has been said and by whom, on what occasion, what are the related events, and so on and so on. But this is context which helps rather understand the meaning of a claim and not so much how the journalist has decided whether this is true or false. And this whole process is quite complex, but I totally agree with you, or kind of as a follow-up of your question, I would say is that if you want to build quality fact-checking systems that do this automatically nowadays, we should really ask ourselves, how do journalists do this job, right? What is the pathway that they follow? How do they proceed step by step in order to come up with their decision at the end, whether something is true, false, or anything in between. And this is where your question is actually very good, because if you look at the way the fact-checking data is used nowadays, even from ClaimsKG, which provides much more context than any other data set currently available, this kind of pathway of decision-making is not really explicitly incorporated. And again, as mentioned, I think to build quality systems, we need to consider that. in this pipeline.
Okay.
I may just have a non-scientific question, but I'm a bit curious. You have built some kind of partnership with the fact-checking organization, or are you allowed to harvest the data, or what's it getting in return?
Yeah, so we are in touch with a couple of fact-checking organizations regarding the building of a European project that we're currently working on. We have contacted all of the organizations prior to publishing their data. Some of them replied, some of them didn't. So we made sure that we respect their policies by looking into what is mentioned on their websites. So this is the reason why, for example, the text of the claim review, so the article which explains the journalistic process of deciding, is not explicitly stored in our data because this is intellectual property that is protected, right? So there are certain limits in that respect, and we have done, I think, what we could to respect those limits. So far, those of the websites that did not come back to us have not yet contacted us saying, "Hey, please take this down because this is intellectual property." I think if you really look into what we're doing, I think everybody would agree that, I mean, fact-checking organization would agree that this is a factual benefit for all of them, right? Making this kind of centralized way of accessing and building links between those distributed data sources. But yeah, the legal issue is very important. So that's also why we are actually working with the legal experts in the current project that we're building.
Okay. No more question in the room. Online, anyone has a question? Antoine. Okay. All right, so if we don't have any more questions, then thank you very much, Konstantin.
Thank you. It was my pleasure.
Thank you. And we may just follow up that discussion in the future because knowledge graphs are interesting for sure. And those are the kind of things we are interested in too. Thank you very much.
Thank you. My pleasure. Have a good day.
Bye-bye.
Bye-bye.